Hi, Tony Zare here, Talking Hands Math, and today I'm going to talk all about proportional relationships. I'm going to give you the ins and outs, what they are, how to represent them, and what they mean. Let's get started. I have my paper here, and I have a few ideas here. I'm defining a few terms. One, a ratio. That's really just a fraction. A fraction such as 2/3. That's a ratio. Now, a rate is a fraction with labels, or a ratio with labels. So I could have 2 miles in 3 hours. So we can immediately see the similarity between a ratio and a rate. You just got labels on there. And usually these labels are two different kinds of measurement, like this is distance and this is time. And a unit rate. Well, it's a rate, so we got to have a rate here, but the denominator is 1. I could start with 12 miles in 2 hours, but that's still a rate. A unit rate would mean I have to divide both of these by 2. And to get the unit rate, you always have to divide by the denominator. So if I divide this by 2, I get 1 hour. And if I divide 12 by 2, I get 6 miles. So the unit rate for this is 6 miles for every 1 hour, or 6 miles per hour. See, the fraction bar is also known as the word per. Okay, a proportion. Proportion is really just two equal ratios. I can take the same 2/3 here. Proportions, two equal ratios. I could take the same fraction, 2/3, and if I double both of these, I would have 4/6. And there is a proportion. You get two equal ratios. Now, how this relates to proportional relationships. I have a table here. And in the table, I have x values and y values. Now, what you got to know is in every table, the x values will always be on the top row, and the y values will always be on the bottom row. Okay, I have some values here. 1, 4, 2, 8, 3, 12, 4, 16. And it's pretty easy to see that to get from x to y, you have to multiply by 4. 1 times 4 is 4, 2 times 4 is 8, 3 times 4 is 12, and 4 times 4 is 16. I could also use this to make a proportion if I wanted to. Since this is this table represents a proportional relationship, I could have 1/4 equals 2/8. See that I took that 1/4 and the 2/8, and I made a proportion out of it. I could do that with any of these. 3/12 is the same ratio as 4/16. And to prove that also, I could take 3 divided by 12. 3 divided by 12. That's 0.25. Now, if I take 4 divided by 16, I should get that same decimal. 4 divided by 16 is also 0.25. See, I got proportional relationships happening here. Now, what you'll also learn about is taking this information and creating an equation. This equation describes everything that's happening in this table here. See, what this is saying is any y value is, because equals means the word is. So any y value is 4 times the x value, and that means 4 times x. So any y value is 4 times the x value. And let's take a look. Any y value, so any of these values, like this one, 8. 8 is 4 times the x value. 4 times 2 is 8. And what we could do, look here, that y value, 12, is 4 times the x value, 4 times 3. See? Now, how I get this here is this is known as, the equation is of the format y equals kx. K is known as the constant of proportionality. I'm going to write that here. Constant of proportionality. And what the constant of proportionality is telling you is, what does it take to get from the x to the y. What is that constant? You're doing the same thing over and over again to get from x to y. What is it? So that's what the constant proportionality is telling you. So to get that constant proportionality, you have to take a y value and divide it by the x value. So the k, the constant proportionality, is the y value divided by its corresponding x value. So I take a y value like, I could do it right here. Super easy. The y value 4 divided by 1. The y value 4 divided by 1. And 4 divided by 1 is 4. And that's where I got the 4 from. See, so it's y equals kx, where k is y divided by x. In this case, it's 4. There you go. Now, to use this in making a graph, I just got to put the points in. Let's see. 1 for the x and 4 for the y. What you have to do is you have to remember the x-axis is the horizontal and the y-axis is the vertical. So the x-axis is horizontal, so that's 1 and then 4. I'll put a dot right there. 1 and 4 is right here. 1, 4. The next one will be 2, 8. Okay, I can do that right here. 2, 8. I'll put another dot right there. And then we have 3, 12. And 3, 12 is right here. And what I'm looking for, what should be happening is I should be getting a straight line. Every proportional relationship makes a straight line. If it's not making a straight line, it's not proportional. And so we have 416. 4, right here. 416, we have 4, and then going up to 16. I'm going to draw a straight line. I'm going to use my ruler. And something else should be coming up too. Let's see, if I do this. There we go. Now, what I hope you remembered I just said is every proportional relationship makes a straight line. And it has to be a straight line that passes through the origin. And the origin is the point 0, 0 on the graph. So right here, it does. 0, 0 on the graph, and it's a straight line. That's the graph of a proportional relationship. What's cool about the graphs are you can just visually see if it's a proportional relationship. If it passes through 0, 0 and it's a straight line, it's over, it's done. You don't have to do all this business of multiplying, dividing, all this kind of stuff with a table and guessing. It's very visual. Okay. I have another example here. Example 2. Now, do we have a shot at this being a proportional relationship? Yeah, it's going to cross the point 0, 0. Now, and what I could do is I can make a graph out of this right away. 0, 0. Okay, 0, 0 right there. Great. 3, 1. 3 on the x, 1 on the y. 3 on the x, 1 on the y. Right there. 6, 2. 6 on the x, 2 on the y. Oh, 6 on the x, 2 on the y. I just noticed this goes by 2's, so this has to be 1 right there. Made a little mistake. Okay, and then 9, 3, 9, and then 3 right there. And I'm going to draw my straight line, which goes right through here, like this. Hey, look at that. It's a proportional relationship. It crosses the origin, and it's a straight line. Now, let's make the equation for this. To review, the equation is going to be y equals kx. But to get k, I have to take a y value and divide it by its corresponding x value. Now, I can pick any column I want, but I don't want to use that one because you can't divide by 0. So how about I just do this one? 1 over 3. Now, students will make the mistake. Remember, I have this as a label here. So the y value is here, 1, and the x value is 3. So k is 1/3. My equation is ready to go. I'm ready to rock. This is y equals k, which is 1/3, times x. What is this saying? Well, it's saying that any y value, like let's take this one right here. This 2, so let me get both fingers. This 2, the y value is 1/3 of the x value. And actually there's another way of writing this. What we could do is we could say this is y equals x over 3. These two equations are exactly the same thing. 1/3 times x is the same thing as x divided by 3. So what we can do here is we can look at this again. The y value, 2, is the x value, 6, divided by 3. And that's right. This y value is 6 divided by 3. I can talk about this. 3. 3 is 9, which is our x value, divided by 3. Easy peasy. All right. Now, you also might see something like this, decimals and missing stuff, and you might be asked, okay, is this a proportional relationship? Now, what we could do is we could take 1.5 divided, I could go one direction here. I could say, well, I could divide each of these. 1.5 divided by 4. That's 0.375. I could take 3 divided by 8. 3 divided by 8. 0.375. If I get 0.375 with all of these, then definitely it's a proportional relationship. 4.5 divided by 12. 0.375. And hopefully, and you have to test all of them though. 6 divided by 16. 6 divided by 16 is 0.375. So the fact that I have the same ratio throughout means it's a proportional relationship. Now there's other ways of looking at this too. I could see something else. I could see that what is the change in y? So the change here, how much did it change from 4 to 8? Well, that went up 4 because 4 to 8 is 4 spaces. How much did it change from 1.5 to 3? Well, that went up. It went up 1.5 because 1.5 plus 1.5 is 3. Okay. Now, I could also see this. But it has to keep on going. It has to be the same change in y and the same change in x all the way through. The change from 4 to 12, that is going up 4 again. So far we're good. And from 3 to 4.5, 3 plus 1.5 is 4.5. Okay, so far everything's good. If this is going up by 4 and this is going up by 1.5, I have a proportional relationship. It should be so far. So this I go up 4 and this I go up 1.5 and okay, everything's good. But you have to think about this. The two parts of a proportional relationship, it has to make a straight line. And this 4 and 1.5, that's going to make a straight line right there. It goes up 4 and it goes over 1.5. But it also has to go through the origin. And we could test that within our table here. If this is adding 4 going to the right, then I would have to test this by subtracting 4. And 4 minus 4 is 0. And if I'm adding 1.5 to the right, I would have to be able to subtract 1.5 going to the left. And 1.5 minus 1.5 is 0. Hey, it does pass 0, 0. And how about we graph it now? Graphing this would be first 0, 0, which is right here. And then 1.5 and 4. I would say 1.5 and 4 would be about here. And then 3 and 8. 3 and 8 right here. It's looking pretty straight so far. And then 12 and 4.5. So, I'm sorry, 4.5 and 12. Oh boy, I almost messed that up. 4.5 on the x and 12 on the y. 4.5 and 12. And I'll make that a little bigger. And then 6 and 16. 6 on the x, 16 on the y. 6 on the x and 16 on the y is right here. Hey, look at that. That looks pretty straight. I'll use my ruler here and draw that straight line. Done. That is definitely, there's two reasons. Here's the table reason why it's a proportional relationship. And here's the graph. Now, what do we have for the equation? Well, that's y equals k times x. And remember, the way you get k is you take the y value divided by an x value. So take any y value, except for 0, 0. Can't do that. So let's just go with easy numbers. The y value, 4 divided by 1.5. 4. Or, you know what? Actually, I guess it might be a little, maybe this is easier. I don't know, it's not that much easier. But 8 divided by 3, I'll take 8 divided by 3. Y over x, 8 over 3. 8 over 3. And you know what? I think I'm just going to keep it like that. K. K is 8/3. That done deal. We don't have to make it, we could make it a decimal. 8 divided by 3 is 2.6 repeating. Yeah, that's kind of messy. I think I'd rather just keep it like that. That's a little bit cleaner. So y equals 8/3 times x. And here's a little secret, 8/3 right there. That right there is if I go up 8, right here, up 8, and to the right 3, I have a point on the graph right there. Amazing, huh? Well, there you go. There's a lot of information on all about proportional relationships. The tables, the equations, the graphs, all this stuff. There's a lot, and what's cool is it's all connected there. And it begins with ratios and then lends itself to proportions, which is why we call it proportional relationships. Well, I hope this has been helpful. Thank you for watching.